Welcome back to the lesson 5 in Pyxel tutorial series. Today we will learn about collision detection techniques. The collision detection strategies can be divided into 3 categories: basic collision detection, advanced collision detection, probably the most popular and most commonly known as a sprite-based collision detection, and the most advanced collision detection. The basic collision detection strategy is based on the fact that the game world is divided into grid cells. If 2 elements appear on the same grid cell, they have collided. The problem of this method is that you need to make sure that your movements are also based on grid, like old Tetris game. Even though it is a very basic collision detection, it can sometimes be used to detect collisions with walls. Not without the problems, as we will see soon. So, to use the grid-based collision detection, I'm going to change player class move left method. I'm checking if the next tile, the tile I'm going to step on, is the wall. If it is the wall, I will ignore the user input. And I also apply the same logic to other moving methods. However, our implementation is not working properly. In some cases, like this one, I can cross through walls. To fix this, we will have to use more advanced collision detection logic. The advanced collision detection is based on sprites. We know that any sprite is a fixed size square area. So, to detect the collision between sprites, we need to detect if there is any intersection of the relevant square areas. This is the best approach for NPC collision detection and also the one we will end up using for walls detection. That's how it would work. If you know the coordinates of the top left corner of a sprite and the sprite size, all we need to do is to check if one sprite is to the left of the other, or if one sprite is above the other. And if one sprite is either far above or far left to the other, the collision is impossible, and we will return false. In all other cases, we would return true. Now, if you enjoyed this lesson, I would really appreciate if you like this video and share it with your friends. It is very easy to do, costs you nothing, but helps me to stay motivated and publish more lessons more often. The most advanced collision detection is based on the fact that sprites will have some transparent pixels. If we use sprite-based collision detection, we will often detect the collision even if the user can't see it. So, to avoid this, we need to check only non-transparent pixel intersections. This would be the most complicated but also the most precise way to detect collision. In our case, I would say it is arguably an overkill. Let's see how we can make a sprite-based collision detection with walls. In every possible situation, we can only collide with 1 or 2 wall tiles. Let's imagine that our player is to the right of the wall and is also exactly on the grid. If we move left, there is only 1 wall tile. However, if we off the grid, we will need to check 2 tiles. Let's change move left method accordingly. It can be easier to assume that there is always 2 tiles to check, up and bottom tiles. Because of the rounding error, we always round down. We can just consider next tile from our implementation as the upper tile. The bottom tile would be the tile immediately below this one. Then we check if any of these tiles is a wall, and if yes, if we collide with any of them. The sprite collision detection function is based on the code from the slide, but was adapted to the code. We use tile size constant and accept 2 pairs of coordinates as an input. Let's see how it works. It has fixed our problem. I have updated all other moving methods in the similar fashion. Now there is one more thing to fix. Because I'm using moving step smaller than 1 pixel, I'm risking to have rounding errors here and there. In other words, I'm risking to stop in a state where my player is shown using integer coordinates, but internal state has some decimal value instead. To avoid this, I will add a special method, stopMoving, which will forcefully round my x and y coordinates to the nearest integer value. Now everything works perfectly. I hope I was able to explain this well. If there is something that's still not clear, please drop me a comment and I will do my best to explain. In the next lesson, I will add sounds to be played when we collide with the walls. It was Test Encoder. See you around!